let's talk about building a service like Spotify. It's one of those classic system design questions. It covers everything from storing just massive amounts of data to delivering it all over the world. But honestly, it's more than that. It's the kind of problem that really shows you the difference between a mid-level developer and a true senior engineer. Okay, let's really get into this. So here's the big question for you. Imagine you're given a totally blank slate and someone says, go build the next Spotify. I mean, where do you even start? It feels like this colossal task, and that's because it is. So let's start by figuring out the actual scale of what we're trying to build here.
First things first, let's set a baseline for our audience. We're going to aim for 500,000 users right out of the gate. Now, that's a pretty big crowd, right? It's large enough to give us some real-world challenges, but it's still a manageable number to start with for our system.
Okay, we've got our users. Now we need the main event, the music. Let's say our catalog is going to have 30 million unique songs. From a data point of view, this is where the sheer size of this project really starts to hit you. And here's the number that changes everything. Those 30 million songs, let's say they average about 3 megabytes each. Well, that comes out to 90 terabytes of raw audio data. And that's not even counting backups or different audio quality versions. This one number right here is going to shape our entire architecture. All right, so you're staring at those numbers. What's your next move? This is exactly where you see that huge difference in how people approach a problem. It's not really about the tech you choose, not at first. It's about the order you do things in. Let's call it the senior engineering pyramid. And what's so fascinating here is how it's completely flipped. A more mid-level approach often jumps right in with, okay, how do I code this? The implementation is the first thought. But a senior engineer, they turn that completely upside down. They start with planning, then they figure out the right tools for the job, and only then, as the very last step, do they actually write the code. So this senior pyramid is really just a way of thinking where all the real heavy lifting, all the most critical work, happens way before anyone even thinks about opening a code editor. The blueprinting, the estimating, deeply understanding what you need to build, that's the massive foundation. The coding part, that's just the tip of the pyramid, the final step in putting a really good plan into action. So let's actually build on that foundation. We're going to start at the very bottom of the pyramid with the most important part of all, the planning. This is where we figure out exactly what we're building and what it needs to be able to handle. So what does this thing actually have to do? Well, at its heart, it's kind of like a marketplace with two sides. On one side, you've got artists who need a way to upload their music. On the other side, you have users who need to be able to find that music and obviously play it. But you also need all the other stuff, like creating your own playlists and having user profiles. And super important, we have to support different audio qualities, from a low bitrate stream to save data, all the way up to a super high fidelity premium version. Now that we know what we need, we can do some back-of-the-napkin math. And this just makes it crystal clear where we need to focus. That 90 terabytes for the actual songs, it makes everything else look tiny. The metadata for all those songs, like the title, artist, album, is only about 3 gigabytes. And the data for all our users is even smaller, just half a gig. So the big takeaway here is that the audio files are going to absolutely dominate our storage costs and our bandwidth. Okay, our blueprint is solid. Now we get to move up the pyramid and start sketching out the high-level architecture. And because we did that planning up front, we can now make some really smart choices about the core pieces of our system and how all the data is going to flow through it. So our high-level design is going to have 4 main parts. Up front, a load balancer is going to act like a traffic cop, directing all the incoming requests. Then, behind that, we'll have a bunch of stateless REST APIs. They handle all the brains of the operation. And stateless is the key word here, because it means we can easily spin up more servers as we get more traffic. For all that metadata, connecting users to songs to playlists, a relational SQL database is perfect. It's built for managing those kinds of complex relationships. And finally, for those 90 terabytes of audio files, we'll use something called blob storage, like AWS S3. You can just think of it as a giant, simple, and cheap file cabinet for the internet, designed to hold huge files reliably. Okay, so let's walk through what happens when you actually play a song. You tap play in the app. That request hits our API, which first checks who you are, then asks the SQL database for the song's info. Now here comes the really clever part. Our API doesn't actually send the song. Instead, it creates a special, secure, temporary link to the audio file sitting in blob storage. Your app gets that link and then streams the music directly from there. This is a brilliant move because it keeps our API servers free to handle other requests instead of getting bogged down sending huge files all day. So, what about the other side of things? Let's say an artist is uploading a new song. It starts off pretty similar. The request hits our API server. After we check the file to make sure it's okay, the raw audio gets sent straight to Blob storage. Then, we pull out all the metadata, the song title, the duration, all that stuff, and save it in our SQL database. One last crucial step is we have to tell our Content Delivery Network, or CDN, to clear its cache. This just makes sure that the next person who plays the song gets the new version. And once that's all done, we send a success message back to the artist. So our design works great for 500,000 users, but a senior engineer, they're always thinking ahead. What happens when our little service becomes a massive hit? What happens when we need to handle 100 times the traffic? Let's put our design through a stress test and see how we'd scale this thing to 50 million users. And wow, the numbers just get mind-boggling fast. Our song catalog explodes to 200 million songs. That means our storage needs jump from 90 terabytes to over 600 terabytes. And our metadata, which used to be pretty small, is now a massive 70 gigabytes combined. Yeah, our first design is just not going to cut it. So, to handle this kind of insane growth, our design has to evolve. We're going to bring in a few key strategies. First, a CDN, a content delivery network. This puts copies of popular songs in data centers all over the world so they load way faster for users. Second, remember how our APIs are stateless. That means we can just keep adding more servers to handle the load. For our database, we'll start with read replicas. Basically, extra copies of the database that only handle read requests. If that's still not enough, we'll move to sharding, which is a fancy way of saying we'll split our database into smaller, more manageable chunks. And finally, we'll do the same thing for our music files with regional storage, making sure a user in Japan is streaming from a server in Asia, not one halfway across the world. And this really brings us right back to the core idea of this whole thing. The real value isn't just knowing how to code all these solutions. It's the ability to see these problems coming, to plan for them, and to think through all the pros and cons before you start building. That's the mindset that truly defines a senior engineer. So, the next time you're facing a new project, whether it's a small feature or a whole new system, don't just dive headfirst into the code. Just take a step back. Think about the scale. Think about the requirements. Think about the architecture. And ask yourself this: what problem are you going to plan first?